Hi guys, so today we're going to go over piecewise functions. Piecewise functions are exactly how they sound. They're pieces of functions. So for instance, x plus 1. So this is an mx plus b equation. Anytime it's x to the first power, which it is here, you're going to have a linear function. So it correlates perfectly with mx plus b, meaning the y-intercept is at 1 and the slope in front of the x is 1, fraction form 1 over 1, rise over run, which means I go up 1 to the right 1, up 1 to the right 1, so on and so forth. So keep in mind when I draw this line, that there is a condition. I may only use this line when x is less than or equal to 0. So here is where x is 0. Anything that is greater than it, because I can only use it when x is less than or equal to 0, anything greater than 0 needs to go. So I'm using a piece of the line, piecewise functions. Okay, if you remember your quadratic equations, and how to graph the quadratic function. It's a parabola at 0, 0, 1, 1, negative 1, 1. That's what y equals x squared looks like. Why am I doing that? Because remember the translation, the aposemo. Plus 2, 2 is being added outside the parentheses. That means I shift each one of these points up 2. So the 0, 0 moves up 2. The 1, 1, I move it up 2. And the negative 1, 1, which is right here, also goes up 2, and there's where my parabola is. However, I'm not keeping this full parabola because I'm only using this parabola when x is greater than 0. So here's where x is greater than 0. I'm keeping this side. Everything to the left of 0 goes away. And remember that it doesn't have an equal sign underneath this 0. So at that point where x is 0, I'm putting an open circle instead of a closed circle. So this is what a piecewise function looks like. They're pieces of graphs. Now, do you have to actually graph this example in order to find the domain? You do not, but I just wanted you to be familiar with piecewise functions as well. So this is my segue into it. To find the domain, we're going to look at each domain for each function, but then from there, we're going to note its restrictions. So for log base 3 of negative x plus 2, I know one thing about a log. I cannot take a log of 0 or any negative value. So anything less than or equal to 0 cannot be used when using log. So this must be greater than 0. And I'm going to subtract 2. I have negative x is greater than negative 2. Then this is being multiplied to negative 1. So I divide both sides by negative 1. And I don't know if you remember this on inequalities, but when you are getting rid of a negative by multiplying or dividing, the inequality will flip. So this is actually going to be x is less than 2. Okay, so from here, I'm just going to note that I could use the numbers for 2 and all the numbers less than 2. However, this is only used when x is less than negative 1. So I can use all the numbers from here on. Everything else not being used because it's not within the condition. So that's kind of my way of notating it for the first one. Now for the second one, I have x squared minus 9x plus 18 over x squared minus x minus 6. Now, I'm going to factor both the numerator and denominator. This will give me x minus 6 and x minus 3. And the denominator would be x minus 3 and x plus 2. There is a whole or removable discontinuity, but in this case, I'm just working on the domain. So I'm going to look for the values that x cannot be so that I can use all the x values that I can actually utilize from here. So I'm going to set each of the factors in the denominator equal to 0 so that I know what I cannot use, which would be x equals 3 and x equals negative 2. These are the two values that I cannot use for the second given function because it would give me a 0 denominator. So I'm going to try to align this with the negative 1 as well. Why am I doing that? Because I can only use numbers that are greater than or equal to negative 1 for x, which means negative 2 does not fall into this category. So I'm not even using negative 2. I just am using 3, which I know cannot be used in the function, and I am only using values to the right of negative 1 because, again, you can only use in the second function, the one in green, numbers that where x are greater than or equal to 1. So to find my domain, I'm going to just kind of take pieces of it. Now, the only number I can't use in the second function is 3. So remember, I'm only using numbers from negative 1 on, so I just can't use negative 3, and that's it. So how am I going to write this domain now that I've made this lovely mess? Well, I'm going to look at what I can use. So starting here from the left, I can use all the numbers from negative infinity up to negative 1. But if I pick up from negative 1, I can still keep going and use those numbers up to 3. So negative infinity to 3. That x means I can't use the 3, so there's a break in the number line, and usually you'll see it notated by union. And then from here, I can go from 3 to infinity. All right, guys, I know it's a bit messy, a bit confusing, but I really do hope it helps.